El Niño. The name rolls off the tongue with a hint of Spanish mystery. It conjures up images of sun-drenched beaches and the rhythmic sound of waves crashing against the shore. But beyond its poetic name, El Niño is a powerful climate phenomenon that has far-reaching impacts on our planet. It evokes images of warm ocean currents and unpredictable weather. These warm currents can lead to the formation of tropical storms, which can bring heavy rainfall and strong winds to coastal regions. But what is El Niño, really? Scientists have been studying this phenomenon for decades, trying to understand its causes and effects. Through meticulous analysis of climate data and weather patterns, they have uncovered the intricate details of this complex system. In essence, it is a climate pattern. This pattern involves the periodic warming of sea surface temperatures in the central and eastern equatorial Pacific Ocean. It is a natural part of the Earth's climate system, but its impacts can be profound. It affects the Pacific Ocean, but its reach extends far beyond. The changes in ocean temperatures can influence weather patterns across the globe, leading to a variety of extreme weather events. El Niño is part of a cycle. This cycle is known as the El Niño Southern Oscillation, or ENSO. ENSO is a recurring climate pattern that involves changes in the temperature of waters in the central and eastern tropical Pacific Ocean. We call this cycle the El Niño Southern Oscillation, or ENSO for short. ENSO has two main phases, El Niño and La Niña. Each phase has distinct characteristics and impacts on global weather patterns. ENSO has two phases, El Niño and La Niña. During El Niño, the sea surface temperatures in the central and eastern Pacific Ocean become warmer than average. Conversely, during La Niña, these temperatures become cooler than average. El Niño brings warmer waters to the eastern Pacific. This warming can disrupt marine ecosystems, affecting the distribution and abundance of marine species. It can also lead to changes in weather patterns, such as increased rainfall in some regions and drought in others. La Niña brings cooler waters. This cooling can also have significant impacts on marine life and weather patterns. For example, it can lead to drier conditions in some areas and increased rainfall in others. Both phases disrupt the normal climate patterns. These disruptions can lead to extreme weather events, such as hurricanes, floods, and droughts. The impacts of these events can be devastating, affecting millions of people around the world. These disruptions have global consequences. They can affect agriculture, water resources, and even the economy. Understanding and predicting these changes is crucial for mitigating their impacts. El Niño events are not new. Historical records show that these events have been occurring for centuries. Ancient civilizations, such as the Incas, documented unusual weather patterns that we now recognize as El Niño events. They have been shaping our planet for centuries. The impacts of these events can be seen in the geological record, with evidence of changes in sea levels and coastal erosion. Fishermen in South America noticed it first. They observed changes in the abundance of fish and other marine life, which they attributed to the warming of the ocean waters. They observed unusually warm waters in the Pacific Ocean. These changes often led to poor fishing conditions, which had significant impacts on their livelihoods. This warming coincided with the Christmas season. The fishermen noticed that these changes often occurred around December, leading them to associate the phenomenon with the holiday season. Thus, they named it El Niño, meaning the little boy or Christ child in Spanish. This name reflects the timing of the phenomenon and its significant impact on their lives. Imagine the Pacific Ocean as a giant swimming pool. Under normal conditions, the water is cooler in the east and warmer in the west. This temperature difference creates a pattern of winds called trade winds. These winds blow from east to west, pushing warm surface water towards Asia. Now picture El Niño as a mischievous child jumping into this pool. The child disrupts the water, creating waves and changing the temperature. Similarly, during an El Niño event, the trade winds weaken. This weakening allows warm water to build up in the eastern Pacific. This disrupts the normal upwelling of cold, nutrient-rich water. The consequences are felt across the globe. El Niño's impact is not limited to the Pacific Ocean. It's like a pebble dropped in a pond, creating ripples that spread far and wide. El Niño affects weather patterns across the globe. In the Americas, El Niño typically brings wetter conditions to the southern United States and the Gulf Coast. The northern United States and Canada often experience warmer and drier conditions. South America, particularly Peru and Ecuador, can face increased rainfall and a higher risk of flooding. Across the Pacific, El Niño's effects are equally dramatic. Asia often experiences reduced rainfall, leading to droughts and impacting agriculture. This can have severe consequences for food security in the region. Australia, the land of diverse landscapes, also feels the heat of El Niño. The continent often experiences drier conditions, increasing the risk of droughts and bushfires. The monsoon season, crucial for agriculture, can be delayed or weakened. Africa, too, experiences El Niño's influence. East Africa often sees wetter conditions, leading to floods and landslides. Southern Africa, on the other hand, can experience drier conditions and drought. Section 5. La Niña, the cool sister of El Niño. If El Niño is the mischievous child warming the Pacific, La Niña is the calming presence bringing cooler waters. This phenomenon is part of the larger El Niño Southern Oscillation, ENSO cycle, which plays a crucial role in global climate variability. La Niña events typically occur every 3 to 5 years, but their impacts can be felt worldwide. During La Niña, the trade winds strengthen, pushing warm water westward and intensifying the upwelling of cold water in the eastern Pacific. This upwelling brings nutrient-rich waters to the surface, supporting marine life and fisheries. The cooler ocean temperatures can also influence weather patterns far beyond the Pacific region. La Niña's effects are often the opposite of El Niño's. While El Niño can lead to warmer and drier conditions in some regions, La Niña tends to bring cooler and wetter conditions. This contrast can be seen in various parts of the world, affecting everything from rainfall to temperature. For instance, while El Niño typically leads to fewer hurricanes in the Atlantic, La Niña can increase their frequency and intensity. The stronger trade winds and cooler ocean temperatures create favorable conditions for hurricane development, leading to more active and potentially more destructive hurricane seasons. Australia, prone to droughts during El Niño, often experiences wetter conditions during La Niña. This can lead to increased rainfall and flooding, which can be both beneficial and challenging for agriculture and water management. The shift in weather patterns can also impact the natural ecosystems, promoting lush growth in some areas while causing erosion in others. La Niña, like El Niño, highlights the interconnectedness of our planet's systems. The changes in ocean temperatures and atmospheric conditions in the Pacific can ripple through the global climate, influencing weather patterns, ocean currents, and even the distribution of marine species. These climate patterns, while originating in the Pacific, have global consequences impacting weather, agriculture, and ecosystems. Understanding La Niña and its effects is crucial for preparing for and mitigating the impacts of these natural climate variations. By studying these patterns, scientists can better predict and respond to the challenges posed by our ever-changing climate. Section 6, El Niño, 2024, Predictions and Projections. As we venture further into the 21st century, understanding El Niño becomes increasingly crucial. This climatic phenomenon, characterized by the warming of sea surface temperatures in the central and eastern tropical Pacific Ocean, has far-reaching impacts on global weather patterns. From severe droughts in some regions to devastating floods in others, El Niño events can disrupt ecosystems, agriculture, and economies. Scientists use sophisticated models and historical data to predict future El Niño events. These models incorporate a variety of factors including ocean temperatures, atmospheric conditions, and historical weather patterns. By analyzing this data, scientists can make more accurate predictions about the timing, intensity, and potential impacts of upcoming El Niño events. This information is crucial for governments, businesses, and communities as they prepare for and respond to these climatic changes. As of early 2025, we are just emerging from a significant El Niño event. The 2023 to 2024 El Niño was one of the most intense on record, affecting millions of people worldwide. In many regions, the aftermath of this event is still being felt, with communities working tirelessly to rebuild and adapt to the new environmental conditions. The World Meteorological Organization and the National Oceanic and Atmospheric Administration predicted a strong El Niño event for 2023 to 2024. These predictions proved accurate. The early warnings allowed for better preparation and response strategies, mitigating some of the potential damages. However, the scale and intensity of the event still pose significant challenges. The 2023 to 2024 El Niño event brought a surge in global temperatures, contributing to record-breaking heat waves and extreme weather events. Cities around the world experienced unprecedented heat, leading to increased health risks and energy demands. Meanwhile, other areas faced severe droughts or intense flooding, highlighting the diverse and widespread impacts of El Niño. The impacts of this event are still being felt and analyzed by scientists worldwide. Ongoing research aims to understand the long-term effects of the 2023 to 2024 El Niño and improve future predictive models. By learning from this event, scientists hope to enhance our ability to forecast and mitigate the impacts of future El Niño events, ultimately helping to build more resilient communities and ecosystems. Section 7. The importance of understanding El Niño. Why should we care about El Niño? Why should we invest time and resources in understanding a climate pattern occurring thousands of miles away? The answer is simple. Our interconnected. Section 8. Preparing for El Niño, a global imperative. Preparing for El Niño is not just a scientific endeavor, it's a global imperative. It requires collaboration, innovation, and a shared commitment to protecting our planet and its inhabitants. We must invest in early warning systems, develop drought-resistant crops, and strengthen infrastructure to withstand extreme weather events. Education and awareness are paramount. We must empower communities with the knowledge and tools to prepare for and respond to El Niño's impacts. By working together, we can mitigate risks and build a more resilient future. Section 9. Conclusion: El Niño and the future. El Niño, the little boy of the Pacific, is a powerful reminder of our planet's interconnectedness. It's a force of nature that demands our respect, understanding, and proactive response. As we look towards the future, we must embrace the challenges and opportunities presented by El Niño and other climate patterns. By harnessing the power of science, collaboration, and innovation, we can navigate the complexities of a changing climate and build a more sustainable and resilient future.